Lecture video for lesson 120, matrix algebra and finding inverse matrices. Now I think if you were in my Algebra 2 class last year, you might remember some of this, or maybe not, maybe it's new. But basically you can take a system, well, we've been solving system of equations with Cramer's rule, so you probably kind of have an idea that you can use matrices with systems of equations. So I would advise you to read this. Basically, what you can do is you write the coefficient matrix and set it equal to the constants, which you've done before when you use Cramer's rule, and see how they have it here. If you multiply this out, 4 times x plus 1 times y equals 7, we'll see how you get that back again. So I guess that's just kind of showing you why it works. But it turns out that you can, you know how when you're trying to solve for x, how you can like divide both sides by the coefficient of x, and then you get x by itself? Well, with matrix math, you can't divide, we don't divide with matrices, but you can multiply both sides of the equal sign by the inverse matrix. And there's a matrix that will undo this matrix. Or in other words, there's a matrix that will get rid of this one. And if you multiply this side by the inverse matrix, that wipes that out, and then you have x and y equal to whatever the right-hand side of the equal sign is times that inverse matrix. Okay, so the inverse matrix, well, it's pretty easy to get the inverse matrix. So hopefully you understand that that's a technique that you can use, is multiply both sides of the equal sign by an inverse matrix. I think they're showing it right down here on page 657. Okay, they're just showing they multiply both sides. Now it turns out when you multiply something by its inverse matrix, you get a special matrix. It's called the identity matrix. And the identity matrix always has ones going in a diagonal, and then it has zeros in the rest of the spots. So in this case, you're just doing a 2 by 2, but you could have a 3 by 3 or any square matrix, and it would have a line of ones going diagonally, and then the rest of the spots would have zeros. Okay, so if you multiply anything by this matrix, the thing will just turn into its own self. Like this matrix times xy is just equal to xy. So I'll do one of those problems for you. How do we find the inverse matrix? Well, this thing's kind of showing you how to do it, but I think it's a little confusing. Basically, you take the determinant of this matrix. So you know how to do determinants, right? You go a times d minus c times b. Find the determinant, and then you get its reciprocal. So if my determinant was like 5, the reciprocal would be 1 over 5. Okay, then you take that reciprocal and you multiply it by this matrix, which you're going to switch the a and the d. You're going to let them switch places. And then the c and the b, you're going to take the opposites of them. So if they're positive, you're going to turn them negative. Let's see, can I show you one? Let's show you one down here. So they're saying the first step is, well, you have to find the determinant, of course. So you're going to go 5 times 10 is 50, minus 6 times 8 is 48. 50 minus 48 is 2. So the thing that you want to multiply is the reciprocal of the determinant, so that'll be a half. And then you're going to take the top left and bottom right, and you're going to let them switch places. See how they did that? And then they left the bottom left and top right, they left them alone except for they changed the signs. And then they multiply. Remember, the half came from it's the reciprocal of the determinant. They multiplied like scalar multiplication, multiplied each one by a half, and that's where this comes from. So that's how you can get an inverse matrix. And then you can use it to solve something if you want. You can multiply both sides by it and solve a system. So we have a zillion ways to solve systems of equations now. We have substitution, elimination, we have Cramer's rule, now we have this inverse matrix thing. So I'm supposed to do number 6. So it just gave me this matrix and I'm supposed to find the inverse. So I found the determinant. I went 3 times 4, or well, negative times negative is positive. I had 12 minus negative 4, and that gave me 16. So I want the reciprocal, so that's 1 over 16. And then I'm going to take these guys and let them switch places. So the negative 4 comes up here, and then negative 3 goes down here. These two guys change signs. It was negative, now it's positive. It was positive, now it's negative. Okay, then I multiply 1/6 by each one of them. Sorry, 1/16. 1/16 times that was that. 1/16 times negative 2 gave me that. 1/16 times 2 gave me that. 1/16 times negative 3 gave me that. This is my inverse matrix. And that's all the problem asked for, but now I get to do number 8. And number 8, I was so happy to find out. Look at number 8. Look at the coefficients. Aren't they the same exact ones that you just did in problem number 6? So isn't that nice of them? I think that was sweet. So they, so we already have an inverse matrix for this because we just found it in problem number 6. Okay, so what we're going to do is write this thing as a matrix. So pretend that part's not there yet. Okay, I just grabbed the coefficients, multiply it times x and y, set it equal to the constants. Then I decide I need to multiply both sides by the inverse matrix to kind of wipe that matrix out. So I already know the inverse because I found it in problem number 6. So there it is. I multiplied these two together, and if you did your math right, you shouldn't have to multiply them together. You should know that they cancel out, but I just wanted to check myself. So if you remember how to multiply matrices, if this is the row 1, column 1, this one's the row matrix, and this one's the column matrix. So you multiply row 1 by column 1. And I'm not going to do all of this. You can check it out on your own. But 1/4 times negative 3 gave me negative 3/4 plus negative 1/8 times negative 2 gave me positive 1/4. Okay, so what? Negative 3/4. Well, it came out to be 1. Is that? Oh, sorry. That is a negative. There's a negative sign right there. You can't see it because of the. Okay, that's negative 3/4 and negative 3. Oh, positive 3/4 plus positive 1/4. It makes 1. So I'm going to run out of time on the video if I do all this calculations. But if you do want to check it, you'll find out you get this. It's the identity matrix. Okay, so basically you wiped these guys out. They're gone. And then you have to take your same inverse matrix and go over here, multiply it by the constants because that's what the right hand side is. And so if you go this times this plus this times this, which I don't have enough time to do all the I did all the calculations up here, you'll get 1. Okay, just do all that fraction math. Oh, that's my finger that's in the way. Do all that fraction math, you get 1. And then go this times this plus this times this. I did some of the work right here. And you'll get negative 4. And this right here is the answer. Okay, and that's it.